Bienvenidos, Hushamdid, and welcome Anne Arundel Community College learners from the CTS 130 Section 402 course during the spring 2021 semester. This is the Cisco Networking Academy Introduction to Networks version 7 course curriculum, and in this tutorial video, we're going to be taking a look at a custom homegrown skills activity from AACC in which you're going to be challenged on your IP addressing and troubleshooting connectivity skill set. So let's go ahead and dive in and take a look at this custom activity. So here is our packet tracer topology. You can see we've got PC 1 and 2 connected into a switch that is then connected into a router that then connects into a switch over here, and then we've got this server. So we're going to examine the IP addressing and default gateways. We're going to test connectivity to devices in the same network. We're going to test connectivity to devices on different networks, and we're going to report on network documentation. So step 1, the network admin has verified that the router IP address configuration is correct, and the addressing table above is also accurate but incomplete. And you can see here PC1 is missing a default gateway. PC2 is missing its default gateway. So we're probably going to have to be sorting that out along with some other tasks. So we're going to investigate the configuration of each PC. So let's take a look at PC1, and we can come over here to the desktop. Now I can click on the GUI, right? Very convenient. I can click on the GUI and see this information. If I didn't have access to the GUI and all I had was the command prompt, I could say ipconfig-all. And this will also show me the IP address configuration. It gives me a little additional information as well. It shows me the link local IPv6 address. It also shows me the physical layer 2 MAC address, those 48 bits that make up the layer 2 MAC address. So we're going to investigate each of those devices, determine if it has the correct IP. And so what is our IP here? Well, 192.168.10.10. Is that correct? What do you think? And we compare it with the addressing table. And remember, we're told the addressing table is accurate, but incomplete. And so if the addressing table is correct, then we are wrong. And we can also tell that it's probably the IP address that's wrong here, specifically the third octet, because in the third octet here, we see 192.168.1.1, which is the gig00 interface IP on the router. So that is probably wrong. And so in order to fix this, here's where we can go back to our config IP tool and simply remove that extra 0 that's there. And we can also fill in the default gateway information for PC1, which is going to be 192.168.1.1. So let's now go ahead and take a look at PC2. And again, we can come to the desktop and look at the IP config tool here. And we see the IP address that it's listed as 192.168.1.20. And that looks pretty good. We look at the addressing table and things look good. And we look at our subnet mask, /24, where the first 3 octets are all 255, 255, 255, or they're all ones, meaning they represent the network portion of the subnet mask. And then we see the default gateway value here. And what we notice is the default gateway for being on the same network, or supposedly on the same network, as PC1. We see that we have a different default gateway address. So now that we've seen this, we take a look up here and we notice that, you know what, that LAN or the default gateway address should be 1.1 on the router. And you can see it's actually listed, the interface is listed there. So the default gateway should be 192.168.1.1. And we can go ahead and close this down. So now here's where they're asking us to start testing some connectivity. So test connectivity to devices on the same network. So what happens if I ping 192.168.1 and I'm on PC2, so 1.10? Can I ping PC1? I can. And if I can ping PC1, I'm pretty confident that from PC1, I can ping PC2. Whoops, sorry about that. Hold on. Messed up on the keyboard here. We'll say ping 192.168.1.20. And so PC1 can ping PC2 and vice versa. And here, they're asking us to connect to the server to check information here. And so let's pull up the command prompt, and let's also try to ping the default gateway for the server, 192.168.2.1, and that is the gig01 interface. Remember, the role of the router in this topology is that it is going to be routing traffic from this subnet, this broadcast domain, this VLAN over here, to this broadcast domain, this subnet, this VLAN over here. And remember, the router breaks up the broadcast domains, right? The router is a device that is used to break up or to segment the broadcast domains. So we're good with our connectivity. We've already tested connectivity for PC1 and 2. Now let's test connectivity to devices on different networks. And we should probably be able to look at the topology and say, I'm probably not going to be able to ping from the server over to either of these PCs. And just simply, again, from a visual inspection, those red upside down triangles should be your first clue that we're not going to be able to get from the left-hand side of the topology to the right-hand side of the topology. It just simply isn't going to work. And so we can see that the connectivity is not there. Now, if the pings are unsuccessful, test connectivity to the default gateway. So we've already tested server connectivity to the default gateway. What about here? Can I ping 192.168.1.1? And again, a visual inspection of what it is we're trying to do here should tell you right out of the gate that I'm probably, from the PCs, not going to be able to get to the router because something is up here, right? These red upside down arrows, those are a bad sign. We'll call those are red flags, right? Think of those as red flags. Okay, so what we're going to be doing now is verify that the router is configured properly. So let's log on to the router here. Let's give ourselves a little more room with which to work. And let's go from user exec, which is indicated by the greater than sign, to privilege exec with the enable command. And let's go ahead and say show IP interface brief. Now, we can easily look at this. There's only a handful of interfaces here. And we see that gig01, which is on the right-hand side of the router, the server broadcast domain subnet side, that interface is up. What if I would have piped it to include up? I could easily see right here that the only interface that is up is the gig01 interface. Now, the gig00 interface is administratively down. Now, the recommendation here is to do a show run, right? And we can kind of hit the enter key or the return key to move through some of the different configuration information. And we can see here that gig00 is in fact shut down. But we also can look, just like with the show IP interface brief output, at the IP address configuration, because we want to confirm that the subnet mask of these interfaces match up with the subnet masks we're using on the PCs and the servers respectively in each case. And you can see it's a /24 with a 255, 255, 255.0. Everything looks good here. So it says make any necessary corrections to test connectivity between the PC1 and the server again. Well, we clearly know that if we go into global config, sorry about that, we go into global config, interface gig00, and I say no shut, you can see that we have one green arrow and then we have the orange dot, and the orange dot is the spanning tree dot. where this port over here, because we haven't enabled a feature that Cisco switches support called port fast, which allows the port to skip certain spanning tree states and immediately progress and transition to a forwarding state, that setting's not on the port that the router is connected into, but now we are green on both sides. So now let's see, can I ping the server? And remember, the server is 2.1. And look at that. We've got connectivity from PC1 through to through to the server. Let's check PC2 through to the server, and that is working as well. And so what's interesting here is it says the ping should test connectivity between the server and switch 1. Ping the switch 1 management IP. All right, which is 1.2. So let's check that out, because my guess is that is not going to work. So 1.1. So I can ping the gig 00 interface on the router. That is not what we were asked to do. I'm trying to ping the switches interface VLAN 1, the switch virtual interface. Remember, this is the interface on a layer 2 switch, which is what we're working with here, 2960. A layer 2 switch, we can configure switch virtual interfaces that allow us to manage the switch. It's a virtual layer 3 interface. Now, remember, not only does that interface have to be up, but we also need to ensure that there's one setting that is a default gateway setting on the switch that needs to be in play. So we can't get to the switch. Well, let's come over here and let's get onto PC2. Can I ping 192.168.1, .1.2. And let me make sure that's right. 1.2. Let's double check that up here. I want to make sure the switch 1. Okay, it is 1.2. All right. So just double checking to make sure we had the right address there. You can see we had an ARP packet go out. We had to wait. We didn't have the MAC address, the layer 2 information. We had the layer 3 info, which was the IP of the switch, but not the layer 2 information. So we had to check on that. So if I can ping it locally here, but I can't ping it from the server, you might think it could be a routing issue, but we've seen that the server traffic is getting routed to PC1 and PC2. And so remember, when you're trying to connect to the switch virtual interface, if it's in a different network, the switch, whatever that management IP interface is, that SVI, the switch virtual interface, we also need, just like on the PCs, where if I come to the desktop here, just as the PCs need a default gateway, right, for the server to be able to reach them, because their ICMP echo replies that are being sent back need to know what the default gateway is, because those replies are not going locally. They're being returned back over here to a different broadcast domain across the 2911 router. So let's get onto the switch and let's go ahead and take a look at things. We'll go from user exec to privilege exec with the enable command, and let's say show IP interface brief, and I'm going to include capital V, lowercase l. And so again, we kind of confirmed this already when we pinged from both of the PCs, or from one of the PCs, PC2 I think it was, that the SVI for VLAN 1 is up. And so this is great. However, we don't have a default gateway configured. And this is one of the more confusing configuration commands and options when we're dealing with a switch. So I want to come in here, and this is how we configure that default gateway. I'm going to say IP default gateway, and then what would the default gateway be? Well, it would be the same as the PC1 and PC2 default gateway settings, 192.168.1.1. Again, any traffic, any control plane traffic that the switch is generating, like Telnet, SSH, whatever the case may be, ping in this case, ICMP echo replies, right? If it's not on that network, the switch needs to know where to send that traffic so that it can get to that network. And so we see that it was up. We're going to add this command in here, and now we'll come back to the server and we'll see, can we ping that 192.168.1.2? Because now the switch knows how to get back to the server. It knows where the default gateway is to send the ICMP echo reply packets so that they can then be routed by the router over to this network segment, this VLAN, if you will, this broadcast domain. Now, I'm pretty sure that these are the same VLAN. I don't think on this switch here that we've got any VLANs configured, but remember, it's the router that breaks up those broadcast domains. It breaks up those subnets. And so the VLANs, as far as the router is concerned, those are irrelevant. That isn't information. Remember, that's layer 2 information. A VLAN is a layer 2 construct. The router doesn't care about the VLANs. The router cares about the source and destination IP. So theoretically, on both sides of this equation, on both sides of the router, we could have the same VLAN. And I'm about to see here, show VLAN brief, if we do. And lo and behold, we do. It's VLAN 1 here. And what about I do show VLAN brief over here? And it's VLAN 1 here. But that's okay, right? That's okay. But something to consider if you're looking at this, would you do that? You probably wouldn't, right? If this is your small office, you might want to put this segment, if it's the third octet is a 2, maybe we make this VLAN 2 over here. And if over here the third octet is a 1, we use VLAN 1. However, you're going to be learning soon in the near future that VLAN 1 is not to be used for hosts or for servers or for access points. In fact, Cisco best practice is that VLAN 1 be shut down and not used. But again, we'll get to that bridge soon enough, but keep that in the back of your mind. Okay, so report partial network documentation using the command prompt and ipconfig/all, investigate and document the following addressing information on the PCs and the server. So we kind of already looked at that. So we'll come over here to the desktop. We'll jump on the command line and let's go ahead and say ipconfig/all. It's asking for the physical address, which we see here for each of the devices. It's asking for using the privileged exec mode command show int, and hold on one second here. So that's how we would see the physical address, the MAC address, and the default gateway address is listed right there. And so walk through each of the devices. You can see here the default gateway for PC1 and PC2 is the same. The MAC addresses, which are globally unique values, will be different. ipconfig/all. They're going to be different for every device we have out here, the PCs and the servers. And ipconfig/all. And so we see all of that information there. So now step 2, it says using privilege exec mode, do the show interface, investigate and document the following addressing information on the router. Okay, so it wants the hardware address. Remember, that's the physical address. That is the MAC address for a specific interface. And so we just simply say do show int. And we can see here, it's that burned in address for gig00. If the activity asked you to get the burned in address for gig01, you would just scoot down a little bit here and find that burned in MAC address, right, for gig01. Because these are the values we should see on switch 1 and switch 2 respectively. So gig00, if I was to say do show MAC address table, we should see that value, where are we at here? So it's going to be gig01. I believe that's the value. Hold on, I just forgot what it was there. What does it end in here? Yeah, Charlie Baker 01. There's Charlie Baker 01. So we've learned that MAC address. Now remember, that will sit in here for 300 seconds or 5 minutes. If there's no activity, then that MAC address entry is going to go away. And then same thing is true on router 2. If I say show MAC address table over here, We're going to see that, what was the, is it Charlie Baker 02? Yeah, it's Charlie Baker 02. And so this switch learned about that MAC address out of Fast Ethernet 01. So that's the local MAC address, the PC's frame, the default gateway. Provide the documented answers of part 4 in the comment box of the Dropbox where the completed PKA assignment is uploaded. So again, you're now going to go ahead and come up here and say File and Save. You're going to save this activity. You're going to upload it. And when you upload it, you're going to put the answers to these questions for 10 points in the description when you do that upload. All right. Well, we saw quite a bit of activity. Again, really good information to be able to find and discover to learn about the layer 2 configuration on your network and the layer 3 configuration on your network. All right, well, that is going to do it for skills activity number 2, where we took a look at IP addressing and troubleshooting connectivity. Thanks so much for watching, and I'll see you in the next video.